Our last topic for the day would be, of course, VSX Graceful shutdown, right, for IGMP and MLD, right? So, and similar agenda, quick overview, use cases, and then jump into details and caveats, some configurations, and then best practices, troubleshooting, and then again, Daryl will take us with a demo. Okay, overview. Here we are. Now, what are we achieving with this feature with our VSX Graceful shutdown for IGMP and MLD is basically resiliency for our VSX network for our acquirers. Now, first thing first, just to make sure, again, that everyone's on the same page, what is basically acquire at the IGMP? Let's just say with IPv4, we have IGMP on our gateways, right, if you may, where let's just say we have a receiver on the VLAN 2001, you have your receivers, clients, and so on. So the multicast receiver, if the multicast receiver wants to join a multicast group, it is using IGMP and communicating basically with the and the gateway here that is acting as acquirer on that VLAN. Right? It needs to know which receiver wants to join which group. So the receivers notify using IGMP to acquirers which they report which multicast group they want to join. And on behalf of those receivers, PIM will communicate with its upstream PIM neighbors. In this case, if we have rendezvous, of course, the message goes to the rendezvous that if you receive multicast stream for this group, forward me a packet. And when the packet arrives, we will forward that packet down to that receiver on that LAN. Well, when acquire, so what is this functionality doing for us, right? Without this feature, right, if the interface in a secondary VSX, so we said this is basically for VSX topology, bringing more resiliency for us, even in the multicast environment with VSX running, right? So when we have a software update, for example, or a reboot occurs, then what happens if our if the interfaces and the secondary VSX nodes are acting as acquire? Let's just say for the sake of argument, during a software upgrade, right? If I'm gonna upgrade my secondary first and then the primary, but when the secondary happens to be the acquirer for certain VLANs, if we go through the upgrade process or reboot, then this could definitely impact the multicast traffic, right? Because we will lose the acquirer interfaces, will be down, and the join could expire for these receivers, right? And then when this feature is enabled, of course, in the case of software upgrade and reboot, the acquire functionality would be offloaded, right? Would be offloaded, and it would be offloaded and to our, in this case, if it's a secondary, then it would be offloaded to our VSX, to our other VSX node. And this function is, of course, enabled by default. And the feature works only, as we said, with, of course, it supports for IPv4 and IPv6. And most importantly, this is for VSX topology, right? Not for a standalone. The nonstop forwarding we were talking about, it was basically for even for a standalone, right? It was basically local to the device, nonstop forwarding. But this, the acquire resiliency is basically the acquire offloading function that we do is basically for a VSX topology. It's not for a standalone topology. And we'll talk about some of the other key things to keep in mind. Let's just go ahead and build on that. And then support platform, the supported platforms basically is any platform so far that we have in a simple way that supports VSX, right? So in this case, our 6400 series, the 8300 series, being 20, 8325s, 8360, the 8400s, and the 10,000s, right? Since this is for VSX networks. Use cases. Well, before we jump into the use cases of acquire offloading, Well, let me come back a little bit and do a quick overview or review of our what was PIM active, right? For those of you that are good with this, no problem. Just a quick refresher number. In our previous codes, we introduced, of course, a while back, definitely, the benefit of active, because what happens in a VSX environment, since again, on this LAN, on this VLAN or subnet where you have the receiver, you have two PIM speaking routers, if you may. Now, when the multicast stream comes down, are we going to send, are we to send multicast, the same multicast stream from this primary and the secondary? Well, that's where the PIM active kicks in for us. Well, one of our VSX peer will become a PIM DR, while the other becomes proxy DR. So then it's the job of the PIM DR to forward the multicast stream, right? Which in the basically the route entries for the downstream ports for the DR are written as routed. Remember in our show IP mroute, there was a state route. So that would be it right here, route. If it's bridge, which would be in the for the proxy DR, meaning it's not forwarding. But they both built, right? Both VSX members both build they will send the join and leave messages and establish PIM peering and of course the shortest path tree, all that good stuff, right? But only the PIM DR forwards the multicast stream. So they're sending the join and leave, and they're basically when they receive the multicast stream, the PIM DR forwards that to the receiver. So we don't send duplicates, right? So that was the function of active, right? PIM active, and we've been supporting this feature for a long time. Why did we want to quickly review this? Because PIM active and IGMP query offload, they go hand in hand. They complement each other, right? So the solution, we do need active because which is handling for the PIM, while query offload is handling the IGMP, right? So let's go ahead here. Now, query resiliency, right? Okay, sorry. So queries are present in a multicast network. The presence of this query in a multicast network is imperative, right, for the traffic convergency, right? And we said the receiver notifies, basically sends a report to the query, and in this case being our gateways, right? A query is most important node, right, in the layer 2 multicast network, as it guarantees, because these periodic queries that we send out here, right? So we send out these periodic queries. Come on. So in this case, once we select our IGMP query on the link, right? And that basically, when the reports are coming in, we will send on behalf of that host using PIM to the rest of the upstream PIM speaking routers, and to forward a multicast stream for that group. So if this query is absent for a large amount of time, this can definitely lead to a traffic loss, right? And then, especially when we're looking at to build resiliency, more resiliency into our VSX nodes, well, when we're doing a software upgrade, we're going to end up rebooting these devices, right? And that could be if for a set of VLANs or subnets that this VSX node on the left was the querer, then when this guy is rebooting, then that would cause definitely a possible traffic loss for a multicast, right? So what we want to do in this case, so again, this will cause traffic loss if the joint timeouts on the non-query devices. The same applies in general for VSX query reboot. Doesn't matter if you're doing software upgrade or a reboot, right? So this will cause an interruption. When the multicast stream comes in, we said there is your multicast stream being pushed down through the PMDR was selected. So this guy is definitely sending the multicast stream. But in this case, maybe in this happens to be the querer was on this device for this given VLAN. So the periodic queries are being pushed down as well on this interface or on that VLAN SVI. Now, prior to this, while basically there was some definitely many change requests were where the traffic loss was in the order of minutes before 10.10. So there was definitely change requests because we have seen some traffic loss prior to 10.10 because of the query. We didn't have the query offloading function. Now, details and caveats. VSX software upgrade, during the upgrade, right? And here we are. How does this function? So then VSX software upgrade, daemon manages IGMP and MLD. Otherwise, basically, if you may, multicast group membership discovery protocol daemon. So when we say MGMD, it's basically it's the daemon that handles basically your IGMPs and then for IPv4 or MLD for IPv6, right? So we'll subscribe to of course, to get the notified when the upgrade starts. VSX daemon will wait for MGMD daemon before starting the reboot. Now, how does this work? As far as when the upgrade notification is received by MGMD daemon, the following actions are taking place. So let's just say in this case, we have our AG1, which is the primary for VSX, and let's just say also query for VLAN 10, 11, 12, right? So in this case, the VSX node, which is basically for going for a reboot, will get a list of its interfaces, right? And set the role in MGMD interfaces, right? So they have added this field, query offload. So the query offload, we set this flag to true, right? And we share that information to our other VSX nodes. So then MGMD daemon will notify VSX daemon to start the reboot, right? But once we notify, of course, the other side, and then the daemon goes and notifies the VSX daemon to start the reboot once the above steps are complete. And of course, one of the other things that we want to make sure your VSX operation needs to be properly operational. The VSX peers needs to be established and fully operational. And one of the other things they communicate, of course, and we would see that in an event, that remote IDL connections are established. So that will basically handle the MGMD messages for query offload. MGMD daemon will take up the query role for those interfaces, right? When we reboot this device, the secondary will take over the IGMP query for these interfaces, the interface that the flags were set as true. Once the upgrade is complete, those flags are basically, the colon is removed and reset. Now, how do we, with the VSX query node reboot, how do we know of when the primary is going to be offline, right? Because we monitor the ISL and the keep alive are used to identify peer reboot. So when the peer VSX node will listen on the ISL link and the keep alive. When the VSX peer reboot is identified, that means the ISL link goes down, right? When the ISL link is down, then we take the new role, we become the querer for those VLANs that the flag that was set, the query offload was set to true. And then we start sending queries. So MGMD daemon on an up and running VSX node will take up the query role for those interfaces that had learned the query on that ISL port. So, all right. Now, And then some um, enhancements and some other details as far as timing wise, right? With 10.10, prior to 10.10, the query plus proxy DR reboot caused basically roughly 30 seconds or maybe more sometimes traffic loss when the query expires and the query election is triggered on the node. So, but with 10.10, that has been improved into sub-seconds, basically, the traffic loss. Some things to keep in mind with wait timers, right? So when the primary, let's just say timers, if we are rebooting the secondary, right? When the secondary gets upgraded, let's say, and comes back online, how long should the primary wait before the multicast grateful shutdown process starts, right? So then, because if we have upgraded the secondary, now when the secondary is back online, then it's the primary that goes offline for a reboot because we have upgraded, we need to reboot it, right? So how long should that primary wait? Well, it all matters based for what number of routes, how much M routes do we have in our tables? For anything less than 1024 M routes, then 120 seconds. If you have a huge number, basically this table kind of helps. You want to allow the secondary to be up online and stable and the tables being populated before the primary then goes offline for a reboot. Caveats, VSX Graceful shutdown, unsupported interfaces, right? End of the day, regardless, right? Query offload functionality will be supported irrespective of the interface type, being, of course, on a routed port, sub-interface point, and so on. But really, it is designed for VSX. So when we think about that a little bit, if it's for VSX network, and I have my pair of VSX, it's for the downstream, right, network, which the hosts are connected. If I have VSX and this is my downstream, so these interfaces are VSX multi-chassis lags, though then they would be SVI interfaces. Really, that's the interfaces that we would configure the active, right, for the PIM DR and proxy DR. And for that also, of course, we would enable VSX, which is enabled by default, VSX Graceful shutdown for those interfaces. So really, when we look at it, right, from that point of view, yeah, PIM active is not currently supported in VSX, VXLAN plus VSX topology. Configurations, again, this feature, MGMD query offload is enabled by default, right? Globally, it's enabled by default. You can disable it. And then some of the show commands, if you wanted to see, because it's by default, if you just do show run, you won't be able to see it. What we can do is basically with keyword all and pipe include MGMD, you will see in your running configuration. And we can take a look at show IP IGMP and also with IPv6 MLD. Best practices, some of the recommendations to keep in mind. Query offload feature works, we said, hand in hand with active feature. Well, a recap again, active is handling the PIM on that host subnet or VLAN, if you may, since we have two gateways, PIM DR and the proxy DR. Let's just say secondary acting as a proxy. And then we would enable, which is enabled by default, the query offloading for IGMP operations, right, on that subnet and on that VLAN, if you may, right, which is handling the host request reports. They want to join which group. Without PIM active, the convergency time on the query when its reboot software upgrades are happening will be high. And of course, won't be proxy DR immediately take place over the DR responsibility, taking over the DR responsibilities, right? So then, yeah, definitely, and this basically the active is required to complete the solution. And for since it's a pretty much required and to basically highly recommended, if you may, and in a way it's actually required, right? Then we need to also look into the best practices of the recommended practices of active in the documentation. All right, so we said this feature is only applicable for VSX networks. And so in the versions without query offload feature, there was another recommendation since there was no query offload. So then to protect, to make sure that IGMP joints won't expire, there was this command, IP IGMP robustness, you would enable. Now with the 10.10, since query offload is enabled, we don't need this IP IGMP robustness configured anymore. And again, of course, you want to make sure that both VSX nodes support query offload, and as long as you have 10.10 and higher Aruba AOS-CX. So they need to both support this for it to work, right? Troubleshooting, again, back to some of the basics as far as the topology, the IP addresses, physical cabling, and so on, and the show commands, right? As far as verification, some systematic or some approach to it. Verify IGMP operations on a VSX lag, the SVIs that are pointing to our host subnet, right? The host VLANs are operational. You have this enabled and so on. Verify that you have PIM active feature enabled. This you have to enable. It's not enabled by default. So then you would enable it on both of the VSX nodes, right? And ensure MGMD query offload feature is not disabled. Because it is enabled by default, it's worth verifying. But yeah, so enable. So if you do show run by itself, you don't see that command. That means it's enabled because by default the it's enabled, and since it's a default, then in the show run command it doesn't show up. You have to use the keyword all. Enable debug IGMP all. We can see some of these messages as far as the query offloading, and then also check the logs. This is important. If VSX peers are in sync, then make sure the MGMD, right? The remote IDL connection established. Once VSX peers are in sync, and then this is telling us MGMD for the VSX peers are also the remote IDL connection established. So we're good to support query offload. Now, show IP IGMP, all VRFs. So we can see the interface being VLAN 2001, query state query here. This switches the query, right? And for these are the active groups that we have heard on this VLAN. And on the other side, we see the same, but it's non-query, right? And then, yeah, so it's a non-query for us on this side. Now, show IP PIM interface. We've seen these commands again, but key thing to zoom in here, right? The interface, we see the designated router and the proxy DR is true here, while on the peer side, right? On the peer, we see designated router and then proxy DR is false, okay? So then we know active is enabled on these interfaces. We have to enable it. They go hand in hand. Ensure that MGMD query offload feature is not disabled. Well, here we are, show run all, or with the pipe, it would be better. Pipe include MGMD, then you would see this one line. Besides that, if you just do show run, you won't see it. And then show debug, right? Because we enabled debug IGMP all here, and debug buffer reverse, so we can see the more recent ones, and include offload. So we can make our search a little bit more easier for us. Query offload event send. This is for IPv6. And then in here, we see query offload event sent for IPv4, IGMP interfaces, right? And then query offload true for interfaces in routed mode. So we said before the reboot process, the query will build its interface, which interfaces, which VLANs, and will set the query offload flag to true and sends it to the other neighbor. So then when it goes offline, the VSX node that is up and running will take the responsibility, becomes the query for also for those VLANs that the flag was set to true for the VSX node that is going offline for the reboot. Okay, show events -R to see the most recent ones include MGMD, and we see in here, key thing to look in here, right? That at the end of VSX operation established, everything is good, then the remote IDL connection needs to be established. Then we know that, of course, MGMP offloading is also set in case we have to go through the process of reboot or software upgrade. All right, Daryl, back to you for the demo.
Okay.
Yep. There you go.
All right. This is my demo environment for the VSX Graceful shutdown demo. You see I have a multicast source at the top that's connected to call 1. Call 1 will forward the stream, both V4 and V6 stream, to the X switches in VSX. So these X switches are the default gateway for the SVI 2001. It has IPs for both V4 and V6. It's connected with VSX lag to an access switch, L2 access switch, that's connected to the receiver, which is dual stack with both V4 and V6 addresses. So what I want to show in this demo is there's a reboot on the IGMP courier. Other VSX switch will take over immediately, and there will be minimal multicast traffic impact. So that's the point of this demo. Let's look at our receiver, see if it sees both multicast streams for V4 and V6. It should be on the 201.10 and DB8 2001 address range. Look at the unicast address, it's 192.168.201 subnet, and IPv6 is on the 2001 DB8 2001, which matches our diagram here. We look at the multicast streams. We have the V4 stream receiving 239.10.10.10, as well as the V6 stream on F38:1. Okay, everything's working. Let's take a look at the X switches next. X1. Let's look at the V4 first. So V4, IGMP on that SVI is the courier. For V6 is the non-courier. Right? You can see here. So it's V4 for this group and V6 for this group. So it's receiving those joins from the receiver. So we're going to reboot this X1 because it's the courier for V4. So if you check X2, it's non-courier. But once we reboot X1, this should become the courier immediately, take over. But for V6, you will see it is the courier. So the reboot would actually impact the V4 traffic, right? Because if X1 reboots, there's no change for the V6. So, okay, with that, I also have debugs enabled on X2. IGMP is enabled debug, so you can see the logs after that. So let's initiate the reboot on X1. Remove this. Here. Okay. It's working for both V4 and V6. Both running. Reboot. Let's reboot it. Continue, yes. Let's monitor the videos. So there shouldn't be any impact for both V4 and V6 streams. Okay, Reboot should have kicked in. Reboot requested. Let's check now. Move this again. Both are still running. Okay. Here, let's check V4. It's now the courier, as expected. Took over courier and V6 as well. No change for V6. It was the courier before, just the V4 took over because of the reboot. So it worked as expected, has no impact to the multicast traffic. Look at the debugs. What do we see? We should see for the June, right? This is the latest one, the June ones, June 1st. Of courier offload events sent for both V4 and V6, IGMP and MLD. So this is now the remaining VSX switch that's supporting all the multicast streams for that SVI, Act 2. Okay. That's the demo. Resources-wise, we've provided links for PIM, SM, and IGMP. And that's it for this topic. Thanks.